Okay, good afternoon, everyone. I hope you can hear me well. Okay, this is the loudest volume I can go. Okay, let's start with chapter 5 first. Okay, for chapter 5, I hope you have a homework with you. Let me share screen. Okay, any point in time, because this is a recorded video, okay, you can pause. Yes, you can pause the screen. Okay, pause your video. You can pause your video and copy whatever you need to copy. But in any case, this set of slides has been shared into Dropbox. Okay. Okay, so for chapter 5, let's begin. Okay, this is the homework. Let me run through some of the questions. Okay, the first question is about seawater. They ask you whether it's like an element, compound, or mixture. Okay, the answer is mixture. Okay, some of you went to explain properties of mixture. Things like can be separated by evaporation to dryness, or is not in a fixed proportion by mass. Okay, so over here, if you state separation techniques or you state fixed proportion by mass, I will still give you the marks, but it's benefit of doubt. Okay, I think generally what they are looking for in this question, very simple for seawater. The definition of seawater is that there are two or more substances that are not chemically combined. Okay, so as long as you state that it's not chemical combined, it is a mixture. There is no further elaboration whether is it fixed proportion or not fixed proportion by mass. Okay, so yes, you must have the keyword not chemically combined. Okay, let's move on. Okay, for this question, I have three things: magnesium nitrate, liquid nitrogen, gas of jar containing air. Okay, the question stated that if it's a mixture, in this case for air, you need to tell me what type of mixture. Is it a mixture of elements, or is it a mixture of compounds, or is it a mixture of elements and compounds? So the answer over here is mixture of elements and compounds. Okay, for part C. And the rest, I think, pretty much straightforward. You need to explain. The question say explain. So based on what you can see in the question, you can tell me it's a fixed proportion by ratio. Chemically combined. Okay, for nitrogen, just one single element. Okay. Okay, next move on. This one quite straightforward. Okay, the only common mistake over here is nitrogen. Nitrogen is a molecule and it's an element. Okay, maybe I do a quick one. What's the difference between atom and molecule? Atom is just one single atom. Molecule is when you have two or more atoms chemically combined. I repeat, it's two or more atoms. Can be the same atom, can be different atoms. Doesn't matter. As long as you have two or more atoms chemically combined, it's a molecule. Okay, then what's the differential element compound? Element is element. Compound is when you have two or more different elements chemically combined. Then you get a compound. So I say again, the keyword is different elements. Then you get a compound. Okay. By the way, nitrogen is diatomic. You just take note. Okay, the next question is hydrogen element or compound? Sorry, is element. It's not a compound because there's only one type of element. Compound requires two different elements. Okay. This was ionic bonding. Nothing much to straightforward. Okay, potassium phosphate is ionic. How do I know? Potassium is a metal. Okay, and phosphate consists of non-metal. Okay, explain why it conducts electricity in the aqueous but not in the solid. You need to explain both aqueous and solid. I repeat in the WA. Make sure you read the question. You need to explain both. Okay, so you can start off with the solid. You need to tell me that why the ions are not mobile in solid. Why? So cannot just tell me they are not mobile. They are not mobile, but the reason why is because they are fixed in position. Okay? Yes, they are in fixed position, so they can move. That's why they are not mobile. As for aqueous, you need to tell me that they are no longer in fixed position. That's why they are mobile. So the extra part, the extra mile that you need to go to explain why they are mobile and why they are not mobile. Okay? And okay, this one you go and read the question carefully. It says ions. Ions. Okay. Formula of ions. That means I must see the charge. Not the formula of compound. Formula of the ions. Okay, this one is in my notes. I think just one small part or one sentence inside my notes. Okay, that talks about charge. In summary, the bigger the charge, the stronger the bond. Okay, the stronger the electrostatic attraction, and therefore you need more energy to overcome this attraction. So I repeat, your answer should have the bigger the charge, the stronger the electrostatic forces of attraction. You need to tell me what type of attraction is the electrostatic force of attraction. If you can tell me between what and what, it's best. Okay. Next, therefore you need energy. So you must talk about the force. You must talk about energy. Energy is very important. So if you need more energy, means it's a higher melting point. Okay. This one, I have a lot of people write something like brittle or what. Can you write the more standard one? Things about electrical conductivity. Okay. So they do not conduct electricity in solid states. Okay. Next one. This one a bit tricky. There are three things. Carbon dioxide, diamond, polyethylene. Okay, they are all different from each other. First of all, carbon dioxide is a simple molecule. The structure is simple molecular structure. Diamond is a giant molecular structure. And the last one is a macromolecular structure. So there are three different structures. Okay. You can check my notes. Under structures for covalent, ionic, sorry, that's not ionic, covalent, simple and giant, and the last one, macromolecules. Okay, increase in terms of melting point, the simple molecular has the lowest, okay, followed by the macromolecule, followed by the giant molecule. Okay. Sorry, let me go back. Okay. Deduce if any of the three can conduct electricity. The answer is no. They are all three cannot conduct electricity. Okay. You must be specific. You must specify both ions and electrons. Why? Because if there's no ions, you still can rely on electrons to conduct electricity, vice versa. So for example, I know electrons, I can still depend on ions. I know ions, I can still depend on electrons. So over here is totally cannot conduct electricity, no matter what the case. So you must be very specific. You must tell me no ions and no mobile electrons. Or if you want to shortcut, just say no charge carriers. Okay? Then, okay, let's move on. This one is ionic because it consists of two polyatomic ions. So it must be ionic bonding. The next one is ammonium. Ammonium itself is NH4. It's non-metal and non-metal, so it's covalent. Okay, so together, ammonium sulfate, is it ionic or covalent? The answer is ionic. Why? Because it involves two ions, two polyatomic ions. The ammonium cation, positive charge, and the sulfate anion, negative charge. So when you have an attraction, electrostatic forces of attraction between opposite charges, it is confirmed ionic bonding. And yes, you need a large amount of energy to overcome this attraction. Okay, and so on and so forth. Can? Yes, you must specify, if you can, what are the ions involved, because they are giving you a specific compound in the question. Okay, this one I want to talk about it. This one is quite straightforward. I have people give me 2 dots for hydrogen. There should only be 1 dot. And that is the one we shared for hydrogen. Okay, what's this? The hydrogen chloride is a simple molecule. Okay, it has a simple molecular structure. Its boiling point is very low. It is a gas. Okay. Okay, next. They ask you to explain in terms of the type of bonding. Okay, can I emphasize this? If they ever ask you to explain why the melting point is low, why the melting point is high, why is it liquid, why is it gas, your answer must have 3 parts. Must have 3 parts. The first part, always tell me what structure. After all, the title of this chapter is about structure and properties. Please tell me the structure. Is it simple covalent structure, simple covalent molecule, simple molecular structure, or is it giant molecular, or is it giant ionic lattice, or is it macromolecular structure? So you must tell me the structure. Okay, next, then you tell me the force. What type of attraction? Is it weak intermolecular forces of attraction? Is it strong? The weak and strong must be there. Is it strong electrostatic forces of attraction between what and what ions? Okay, so you must tell me the force. And after that, you conclude with the energy. So do you need more or do you need less energy to overcome these forces? So over here for hydrogen chloride, is simple molecular structure. So tell me it's a simple molecular structure, or you tell me it's a simple covalent molecule. You tell me the force. It is a van der Waals, or you tell me weak intermolecular forces of attraction between the molecules. Then you tell me about the energy. So you don't need so much energy. You only need a little bit amount of energy to overcome this weak intermolecular forces of attraction. Therefore, the melting point is very low. Okay, I repeat, these 3 things must be there. Very important. Okay. Okay, I hope you know what's allotrope. I will not talk about it. The answer is graphite. State 2 properties of graphite. If you tell me soft and slippery, these 2 are considered 1. If you tell me good conductor of heat and electricity, it's also considered 1. Okay, so you must give me 2. So soft and slippery is only 1, not 2. Okay, please take note. Melting and boiling point also considered 1. Okay, next one. Versus lubricant. Okay, they give you this molybdenum disulfide, and they tell you it's a poor electrical conductor. Okay, if you cannot conduct electricity, basically there's no electrons. It is not ions. Okay, there's no ions, so we just focus on electrons, because you look at the bonding, it's all covalent bond. Okay, I hope you see the question, the picture, you know, is covalent bonding. So covalent bonding has no ions. So your answer don't need to talk about ions. You just focus on the electrons. So in this part of the answer, tell me there is no mobile electrons. Why? Please tell me why there are no mobile electrons. Because all the valence electrons are already used for bonding. So there is no mobile free electrons. Okay, don't need to talk about ions. There's no ions over here. It's standard, it's all covalent bonding. You look at the picture, all covalently joined. Okay, okay, let's move on. Okay, where's my C? Always the C is missing. You must tell me it's a C of electrons, or better still, C of mobile electrons. So the C is very big. So you tell me, oh, there's a lot of electrons. It's like a C, and all the electrons are mobile. Okay, so my C must be there. SEAC. Okay, gallium is a metal, so it's metallic bonding. Metallic bonding, you must talk about what is the force. It's a strong, the weak and strong must be there. It's a strong electrostatic forces of attraction. Between what and what? Okay, between the gallium cation and the sea of mobile electrons. There is no negative ions. I repeat, this is metal. Only one element, metal. And metal form positive ions. There are no other element. There are no other negative ions. Okay, it's just the positive attract with the electrons. Metal. That's why metal are good conduct electricity. They have a lot. They have a sea of mobile electrons. Okay. And no negative ions. Don't talk about what negative ions attraction. This one you just read the definition. What is malleable and ductile? Okay. This one not much comments. This one, I write down the word take reference. If you cannot understand what my handwriting, okay, the word is reference. What do I mean by take reference? Okay, I know it's quite different from my notes. In the event, if the question already give you a sample, then please follow the sample. So for example, in this question, they will show you what is pure iron and how big the iron atom is. So just follow the same size. Cannot I become alloy, then the atom of the iron size changes. No, my iron atom is still iron atom. The size is the same. However, because I've added carbon, but I don't add a lot of carbon, it's still mainly iron. Otherwise, it become non-metal with too much carbon, very weak. So it's still mainly iron with some carbon atoms. You just draw in the some carbon atoms. Okay, and carbon is smaller in terms of the size. Okay, the number of protons, the size. Carbon has less proton, so it's the size of the carbon atom is smaller. So just go and draw the respective of it. Okay. Most important, I must not see layers. Okay, must see some jumbling up. Can okay. Take reference from the question. Yeah. Okay, this one, the C is also missing. Okay, explain why metals are good conductor of electricity while the other one is a poor conductor. So your answer must have both metal and the simple covalent. So for metal, very straightforward. You must tell me there's a sea of mobile electrons for you to conduct electricity. Whereas for the other one, there are no available electrons. Don't talk about ions. This one is covalent bonding. There is no ions in covalent. So for covalent, don't tell me what, no free mobile ions. In the first place, there's no ions. Okay, so for covalent, you focus on electrons. You tell me there are no mobile electrons available. And why? Because all the electrons have been shared or have been used for covalent bonding. Okay, can don't write nonsense. This one no ions. It's just electrons. Okay, next one. Solid. Okay, so for solid, you must also explain both metal and ionic. Now it's ionic, so must have ions. So for solid metal is always metal with C of mobile electrons, so that's why it can conduct electricity. For ionic, if it's solid, they cannot. You must tell me why cannot. You cannot just tell me there are no mobile ions. But why isn't the ions not mobile? It's because they are in fixed position in a solid state. Okay? Yeah, don't just tell me there are no mobile. But why are there no mobile ions? Ions, not electrons. Okay? Okay, next one. Why molten both can conduct? Yes, you must tell me, say metals, they still have the C of mobile electrons. For ionic compound, the ions are now mobile because, please tell me why. Why are they mobile? Ions are not electrons. Ions are now mobile because they are no longer in fixed position. Because it's molten. Okay? Can I hope it's clear enough. Any questions so far? So far, so good. Can okay, let's move on. Okay, next one. Copper is malleable and ductile. Okay, this one I think no issue. Basically, the layers can slide over one another easily. And next one, copper can conduct electricity. Yeah, because C of mobile electrons. Copper is a metal, metallic bonding. Okay, now I move on. Why copper has a high melting point? Okay, as mentioned before, you must state, yes, you must state the three things. First, tell me the structure. Okay, it's a giant metallic. I repeat, as metallic, not ionic. This is metallic bonding. Giant metallic lattice structure. Next, what is the force? Strong electrostatic force of attraction between the positive copper ions and the negative C of mobile electrons. This is the force. Okay. Then you talk about energy. You need a lot of energy or large amount of energy is needed to overcome. Okay. Okay, let's move on. Oh, okay, this one I did not mark. Yeah, this last page I leave you to mark. So basically, there are two things, X and Y. They ask you to determine the identity of X and Y. Not much information is given except that one boils at 100 degrees Celsius because that is supposed to be distilled water. So if you want to check which is distilled water, the easiest way is go by boiling point. Okay, so just boil the two liquids and check their boiling point. If the one that boils 100 is distilled water, then the other one will be potassium chloride, which the boiling point is above 100 degrees Celsius. Okay, if not, you can just evaporate to see which one contains a residue. Okay, distilled water evaporate, left nothing. Okay, so you check the answer. It's either you check the boiling point or you go and evaporate. But of course, if you got other option, you just PM me. Okay, next one. They ask you, you can conduct electricity. What can you conclude about the bonding? Okay. For potassium chloride, I think you know it's ionic bond. Okay, so quite standard. But if they tell you that it can conduct electricity, means yes, there are charge carriers. In this case, there are ions to conduct the charges. So it is ionic bond, not covalent bond. Okay? Can? Because the other one is distilled water covalent, but it's a better conductor, so it must be ionic. Okay. Okay. Next, they introduce a new substance again, compound Z. Compound Z has a melting point of 102, does not conduct electricity in any state. So it must be covalent, because covalent cannot conduct electricity in any state, except for graphite. But this is not graphite. Graphite don't have so low melting point one. Okay, so the melting point is 102. Is covalent and is a simple covalent. Why? Because the melting point is not so high. Giant molecular structure will be very high. So it must be a simple molecular structure. So answer is simple molecular structure. Okay. Any question? No question? Okay, no question. I think yes, that should be the end. So this will be the end of chapter 5. Let me stop my recording first. Stop share. Okay. And I stop my recording.